Okay, students, we are going to discuss the third type of optoelectronic devices. Previously, we discussed about the photodiode and LED. Now we are going to discuss about the solar cell. These are the three types of photodiodes. Optoelectronic devices are three types. Optoelectronic devices are three types. First one is the photodiode, second one LED, third one solar cell. In that first one, second one in the previous lecture we discussed. Third one, solar cell, I am going to explain. These are very important. A device which converts the solar energy into electrical energy is called as solar cell. Solar cell means it is a device which converts the light energy into electrical energy. How it will works? You see this construction of the solar cell. It is also PN junction diode, right? It has the P region and N region. Okay, and now here this is the PN junction diode. Below the P there is one metal attached. Above the P there is a some fingered metal is attached. Then the N region is a very thin layer. When the light falls on the N region, it is made to incident at the junction. Okay, and through this fingered metal, why we are using, because the light is allowed to incident on it. When light falls on it, what happens? And then this solar cell working, okay, similar to photodiode, right? Same as photodiode, but in the photodiode we are using we are doing the biasing. That means we are connecting in the reverse bias by using battery. It is a cell, we are not connected to any battery, right? It only generates the current. How it will generate, I will explain. It will convert the light energy into electrical energy. That means light is allowed to fall on the diode, that will generate the current. How it will generate, we will discuss. When the light falls on the diode, in three steps it will convert the light energy into electrical energy. The three steps are generation, separation, collection. What is generation? When light of photon, okay, light of photons whose energy is greater than the energy gap is allowed to incident at the junction, electron holes are generated. That is a generation process. These electron holes are separated due to electric field, because electric field is there in the depletion layer. The electrons are attracted by these positive ions, that's why they are collected in the N region, and the holes are collected in the P region. Okay, and due to electric field depletion, electrons are collected in the electrons and holes are separated before they recombine. The second step, second separation. Third step is the collection. Electrons are collected in the N region, holes are collected in the N region, and on both sides one metal is attached. Then one side electrons and other side holes. That means one side it will become the positive charge. P region is collected the holes. That means it will become the positive charge. And N region is collected the electrons. That means it will become the negative charge. Then there is some potential difference is there between both sides. Okay, right? And then it acts as it can, if we connect that diode to what happening here, this is a PN junction diode. When light falls on it here, one side become positive and other side become negative. That means it will act as a battery. When we will it has some potential difference at here. Okay, that is in the open circuit, there is some potential difference is there. If you connect to some load resistance, then the current will be flows. IV characteristics of solar cell, you remember this graph. In the open circuit, no current, that's why this current is taken on y-axis, voltage is taken on x-axis. At the open circuit, what happens? In the open circuit, current will be zero, voltage will be more, right? When you connect to this diode something short circuit, okay, then at the moment current will reaches the maximum, potential will become zero. This is the, here VOC indicates the open circuit voltage, ISC indicates the saturation short circuit current. Okay, and now let us go for the which type of material we have to select to make the solar cell. The criteria for selection of material for the solar cell. The band gap should be between the 1 electron volt to 1.8 electron volt. You have to select a semiconductor material to make the solar cell whose band gap between the 1 electron volt and 1.8 electron volt. High optical absorption should be there. Why? What is the need of the band gap between these? Actually, generally in the daytime, light will be false. Light energy is between the 1.8 to light energy. Okay, it is up to 1.8 electron volts. The band gap should be between the 1 electron volt and 1.8 electron volts. The next, then only when light falls, the electron hole pairs will be generates. And high optical absorption. More light should be absorbed, then more electron hole pair generates, then more voltage will be generates. Electrical conductivity is more. And availability of raw material. To make the solar cell, raw material should be available. Cost. With these all the criteria that we have to check during the selection of the material for the solar cell. What are the uses of the solar cell? Solar cells are used in the solar panel, right? Nowadays we are using the solar energy. Solar panel is the combination of solar cells, group of solar cells, right? They are used in the satellite and space vehicles. They are used in the light meters in photography, and they are used in the calculators, right? Solar cells are used to charge the batteries in the daytime, and that batteries are used in the night time. These are the uses of the solar cell. Thank you to all.